All right, welcome back. This is question 8. And so we're going to do partial fraction decomposition on this integral. So first we're going to let a be x over x plus 5 and plus bx plus c over x squared plus 4. All right, now we can rewrite this by multiplying across. So we have a times x squared plus 4, and then plus x plus 5 over bx plus c. Now we expand. We have ax squared plus 4a. And then we have plus bx squared plus 5bx plus cx plus 5c. All right. Now our coefficients for 1 is just going to be 4a and 5c. So we have 1 equal to 4a plus 5c, 0 for 5b plus c. That's for our x's. And 0 for our x squared, which is just a plus b. And then solving this system of equations is going to yield us solution of a equal to 1 over 29, b equal to negative 1 over 29. Makes sense. Then c is equal to 5 over 29. Okay, so we can rewrite this as our integral from -3 to 3, 5 minus x over 29 x squared plus 4 plus 1 over 29 x plus 5. Alrighty. Now we factor out the constants and add another integral. This should look familiar from our trig section. And then this should just look like a normal integral. Oh, I forgot to factor out the 1 over 29. There we go. And this should be a very simple integral when we get to it. We're going to know in the back of our head that's just going to be 1 over 29 log x plus 5, evaluated from -3 to 3. But first, we're going to split this up even more. This first integral, we have 1 over 29, -3 to 3. Split this up to 5 over x squared plus 4 minus x. So we're splitting the numerator. X squared plus 4 dx. We're just going to worry about this part. Now we can factor out again and do another integral where we have 5 over 29 -3 over 1 over x squared plus 4, and then minus 1 over 29 -3 to 3 x squared plus 4. This integral dx. This integral is going to be evaluated at 0, so it's going to fully cancel out. So we're just left with 5 over 29, integral of -3 to 3 over 1x squared plus 4 dx. And then our original, this integral. But first, we're going to evaluate this one, where we're just going to factor 4 for the denominator, move it up here. 5 over 29 -3 to 3, 1 over factor the 4, x squared over 4 plus 1 dx. I factor out that constant, 5 over 116, -3 to 3, 1 over x squared over 4 plus 1 dx. We let u equal to x squared over x over 2. And our du is equal to 1/2 dx. So, and it's going to give us new bounds of u of -3 over 2 and u of 3 over 2, respectively. So, plug that in, 5 over 58, integral of -3 halves to 3 halves to 1 over u squared plus 1 du. And now this looks like our inverse tangent, thankfully. So we have 5 over 58 of inverse tangent of u, and we plug in our bounds. That's it, just going to simplify to 3 over 2 after we simplify everything. Oh wait, we're getting 1/2 though from that, so we multiply this by 1/2. So 5 over 29 inverse tangent of 3 over 2, plus our last integral of 1 over 29, integral of -3 over 3, 1 over x plus 5 dx. And thankfully, we know that this is just going to be 5 over 29 inverse tangent 3 over 2 plus ln of 3, or it's going to be ln of 8 over 29 minus ln of 2 over 29, which would be our final answer. Oh, and yeah, that's our final answer. And that is equivalent to 0.21725 if put in the calculator. That is question 8.